Welcome to Answer Everywhere. We're taking a look at some source code, like we always do. We're just poking around the internet, looking at source code we haven't seen before. That's the thing that we do on the channel. And I'm taking a look at unsloth. I figured I don't know anything about fine-tuning LLMs. We've looked at a bunch of AI-related code. We've looked at AI libraries like PyTorch. We've looked at the compile time libraries. We've looked at even some of the GPU stuff, including some hardware, Verilog, that sort of stuff for GPU, adjacent thingies. And you can find all that on the channel. You should go around and explore. But I don't really know much about fine tuning. And by much, I mean really anything. So we're going to look at unsloth. I don't know if unsloth is still the go-to. I know at least a few years ago, people were always talking about it. That could be hype. That could be marketing. That could be reality. I don't know. But I figured it was a good place to look. And I guess let's talk a little bit about what we expect to see, or what I expect to see. Not really knowing anything. And that is, they're probably going to do reinforcement learning, first of all, because I think that's in general how it works, and also because it says it's reinforcement learning. And so what are they going to reinforce? I don't know if they're going to have like a good prompt, bad prompt, or something along those lines. And not good prompt, bad prompt, but good response, bad response. But they're going to have some sense of, I think, which responses are good and which responses are bad, and use rewards to perturb the model weights. So if we have some sort of open model, like for example, it mentions here Kenn, Llama, and DeepSeek and Gemma. And it says 2x faster with 70% less VRAM. Although, this says TTS 2x faster. I don't know if that's supposed to be modifying TTS or text-to-speech or something else. But at any rate, I think that probably what they're going to do is they're going to have the same prompt encoded in the thing the matrix of the matrices of the models want to consume, so that it is after tokenizing and embedding. And then they are going to evaluate the model and have some expected output and see what the model output is. And then they're going to do something between those two, maybe cross entropy, maybe something else. And that's going to, the cross entropy is going to give some measure of goodness. And then using that measure of goodness, they're going to do somehow perturb the weights. And I don't know exactly how that works. So reinforcement learning often has like a policy, but I don't know. But anyway, so that's sort of kind of what I expect going in. Just to articulate that somewhat for myself and somewhat for everyone else, so that we have a sense of what to look for. And there's a bunch of stuff. This is a big README with emojis. Emojin. What's the plural of emoji? I don't know. But here we are. We have a data prep, kernels, models, registry, and then a bunch of stuff like tokenizer utils and trainer, and chat templates. I'm going to take a look at trainer. Registry, who knows? That might be like a registry of models. Kernels is probably cool. Data prep is probably actually important, and also models. Did I already do models? I don't think I did. Okay. So that's all the things. Utils might have cool stuff in it, but we're going to skip it for now. And then we have this Blackwell folder, which is presumably for Blackwell. Unsloth Blackwell compatibility. So Blackwell's NVIDIA chip or architecture. It's a micro architecture. It's a GPU. I don't know what makes it a microarchitecture rather than like a specific kind of chip. Maybe it's I don't know at what level of the design the microarchitecture is, but it's the next generation stuff. Or maybe it's current generation. I don't know what its status is. Will it tell me what year it was released? It was leaked in 2022 and officially announced in 2024. So this must be... I don't think they have anything more recent than that in the market currently. Stop this. Oh, tab grouping. I'll look at the code of conduct. I'll look at contributing. I don't know why. Let's just do it. And then there's this fine tune for free. Notebooks are beginner friendly. Start for free. I don't know what this means. Does unsloth have a paid service? Hello, wizard. It's good to see you. So I don't know what start for free means. Did we already open this? Let's open it in a new thingy. Okay. To run this, press runtime. So this will go to unsloth.ai if I click that. But I don't know. I'll see if there's an API. So this is the GitHub stuff. We're going to install Torch and Triton. What is Triton? I thought it was like a GPU thing. Some compiler maybe? Development repository for the Triton language and compiler. Oh, I think it's maybe the CUDA language. At any rate, we'll just assume it's something like that. We are about to demonstrate the power of OpenAI GPT OSS 20 billion models through the fine-tuning example. From unsloth, import fast language model. Import Torch. Max sequence length is 1024. I don't know if you just get to set that. Is that something specific about unsloth? Or rather, something specific about this model? And it's using the bits and bytes. This is the 4-bit quantized version. Bits and bytes is some library, I think, for quantization. And they're grabbing it from, I guess, Hugging Face, as you do. And then this fast language model has a constructor from pre-trained, which is presumably grabbing essentially a snapshot. But the model, I guess, is a snapshot. So you're telling it the model name and the D type and the max sequence length. Choose any for long context. Choose any. Like the literal any? I don't know. And then full fine-tuning is false. New, we have full fine-tuning now. And then there's a thing for a token, which is use one of using gated models. I don't know what a gated model is, but this is I don't know which kind of token this is. A model with access requests enabled is called a gated model. Maybe this is like an API token for Hugging Face, as opposed to a token in the sense of AI or ML. And they're going to add LoRa adapters for parameter efficient fine-tuning. This allows us to only efficiently train 1% of all parameters. So they've got a get PEFT model. I think we've seen PEFT before. I don't remember exactly what it does. You pass in the model from before. This is just reusing the variable model, I guess, and also reassigning it. Set R to 8, whatever R is. And then we've got a list of target modules. And these are maybe, I don't know how you get these, but these are, I'm assuming, like different, I don't know if you would call them layers or modules in the AI world, but these are essentially different linear algebra things, I assume, that are chunks or lists or groups or bags of floats, the essentially matrices and vectors they add to them and that sort of stuff, the parameters. And then the LoRa alpha is 16. I don't know what alpha is configuring. And then 0 dropout. 0 is optimized. I don't know why. No bias. 0 is optimized might mean that if you put in 0, they will like learn somehow the optimal dropout, and similar with bias. I don't know. And then gradient checkpointing is either true or unsloth for a very long context. Okay, I'm not really sure what that's. This is some sort of checkpointing configuration. I don't know why the literal unsloth is used, but and then some random state. I'm assuming this is just like a random seed, and whether to use RS LoRa and whatever loft Q config is. And then reasoning effort. The GPT OSS models from OpenAI include a feature that allows users to adjust the model's reasoning effort. This gives you control over the trade-off between the model's performance and the response speed, latency, by the amount of token the model will use to think. And so I didn't realize this was configurable even for the open source models, but I guess that makes sense. I don't really know how that works. I guess in the model code, they just have some, like a fixed amount of, maybe they're just going to like wrap it in thinking tokens or something. At any rate, we have a message, just a single one. The role is user, and the content is solve x to the 5th plus 3x to the 4th minus 10 equals 3. Presumably solve for x. And then we call tokenizer. So we're going to tokenize apply chat template. So the tokenizer is chat template aware. I think that makes sense. And then add generation prompt is true. I don't know what the generation prompt is going to look like, but return tensors is PT. I don't know what PT is. Return dict is true. And reasoning effort is low. And then after we tokenizer, apply chat template, we're going to call to model.device. So I think this is just like we're taking the device should be, I think, just the GPU, essentially, assuming you're on a GPU and not a CPU. I don't know if they support CPU, but at any rate, we're just grabbing the device to do CUDA stuff too, I think, and telling the tokenizer to run there. And then we're going to call model generate, passing in the inputs, which are the tokenized things here, with ***, setting max new tokens to 64. I'm guessing max new tokens is like that. This is we have thinking. I assume it's like we have thinking tokens already, and this is maybe the stuff after the thinking tokens. And then some streamer, which is a text streamer of tokenizer. So presumably the text streamer needs to know about the tokenizer because you're going to stream the tokens, and text streamer is going to convert them to something that your terminal can print, like UTF-8. And then it looks like this: start system message, you are ChatGPT. By the way, I usually don't read the documentation at all on this show. I am today because I think this is going to help me understand the code more. Okay, reasoning effort is low. It's going to print that out, I guess. Tells you what the knowledge cutoff is. This must be from the model. The reasoning effort is low. Current date is whatever this is, 813. Valid channels. I'm not actually running this, by the way. I didn't even realize I was logged in. I probably could run it. Okay, calls to these tools must go to the commentary channel. Valid channels are analysis, commentary, final. Okay, this is maybe something about the model. I don't know. This is maybe something from the Transformers library. I don't know where this stuff comes from. This channel stuff. At any rate, we've got these end and start tokens. I assume that these are just like UTF-8 printouts of the tokens. Or maybe you like literally type these and they get tokenized, and that's what the real token is. I don't know. And we have start user message, solve this, blah, blah, blah. Start assistant, channel analysis, message, equation. And it's going to print out this thing. So x to the 5th, blah, blah, blah. Solve for real roots, maybe numeric. Let's try approximate. Calls to these tools, blah, blah. Okay. And so it's going to try to test for integer roots. Okay. Changing the reasoning effort to medium will make the model think longer. Yeah, that makes sense. And it just kind of like passes out here. And then there's data prep. Multilingual thinking dataset will be used as our example. This dataset, available on Hugging Face, contains a reasoning chain of thought examples derived from user questions that have been translated from English into 4 other languages. It is the same dataset referenced in OpenAI's cookbook for fine-tuning. So we have data formatting prompts func of examples. And convos is going to be examples of messages. Examples at messages. So that presumably the example contains a list of messages like a dict among which are some messages. And then we're going to convert them all to text like all at once with this list comprehension. And we're going to return the text. And then the data set, we're going to say load data set with split equal to train, the string train. I don't know if that's the training split is a property of the data set or if the library just knows how to split it up. All right, and then they're going to format the data set. And they're going to print it out, or at least print one of them, and it looks like this. You are ChatGPT, alert. So we're going to train it, telling it that it's ChatGPT. I guess that's okay, because they are using the ChatGPT model. Standardized share GPT. Okay, so they do formatting, and that's presumably what this stuff is. Reasoning is medium. Reasoning language is French. A lively and energetic personality. Can you show me the latest trends on Twitter right now? And is this the translation? No, it's responding. Sure. The user is asking the trends on Twitter, the most recent, etc. Okay. And then we train it from TRL, Title Request Live, SFT config, SFT trainer. We've got this SFT trainer class that takes a model, a tokenizer, a training data set, and a config class that includes things how like per device train batch size is 1, gradient accumulation steps is 4, how many warm-up steps. I don't really know what they do with warm-up. Maybe they just run the training and don't record stuff or something. And then max step, learning rate, etc., weight decay. So this is just normal training stuff as if you were training a model from scratch. And then we're going to call trainer.train. And we've got some loss. And we're going from 2.13 to 1 point something. That doesn't seem like a great loss. And then we can do inference. Whoops, no. So apply chat template. This is just again, templating and tokenizing and asking this question. Reasoning language French, you are a helpful assistant that can solve mathematical problems. And I guess it's gonna reason in French, but maybe output in English. Is that what we did up here? It outputs both French, I think, unless I'm missing the thinking tag. Is there a thinking tag? Okay, so we have assistant channel final. So maybe the analyze is the thinking tag. The analyze channel, is that what this is? Analysis? Okay, great. All right. And that's training. But somehow how do we get the model that we trained? We called trainer.train, passing in the model. So I guess we're just going to mutate the model. So now when we call model.generate here, it refers to a model that was mutated in place or something. And then you can save the fine-tuned model. Okay. So all of that was useful to me. Was it useful to you? That I can't promise you. I still don't know what start for free means. I don't know if they also offer some sort of pay service. Is that worth looking at? Where is start for not free? Where's pay through the nose? Unsloth.ai. You can start for free. How does unsloth make money? Money P. DuckDuckGo's search assistant will tell me. Okay, they do offer a platform for fine-tuning. They likely generate revenue through subscriptions, service fees, partnerships, etc. Okay. All right, so we're going to ignore Blackwell. We're about 24 minutes in, and we're going to look at some code now. Warnings. Import warnings. Okay, so based on the code that we saw, should I open that back up? I'm going to just open up. Performance is 1.5x faster. Then what? Then what? I don't really understand what the claim is here. But at any rate, we've got this. Okay, no. Where did that go? That's that. So what I think we're doing is we're using LoRa's, right? If you're a beginner, it's best to start with a small instruct model like Llama 3.1 8B and experiment from there. You also need to decide between QLoRa and LoRa training. LoRa fine-tunes using small trainable matrices in 16-bit without updating all model weights. And QLoRa combines LoRa with 4-bit quantization to handle very large models. So I had thought that LoRa was basically, you have an adapter model that's a smaller matrix, and you're tuning sort of like a filter. But maybe I'm not understanding what LoRa is actually doing. Let's see if we can find about LoRa. Low rank adaptation. So this is, LoRa doesn't even get its own article. It's just in fine-tuning deep learning. An adapter-based technique for efficiently fine-tuning models. The basic idea is to design a low-rank matrix that is then added to the original matrix. Okay. So the matrix is full size but low rank, I assume, because otherwise addition could not be defined. And so we are adding this to the, we have matrix A, and we're going to create matrix B. I can't draw here, but we're going to create matrix B so that B is the LoRa, and then A plus B is the new model. So B is like a perturbation of A in some direction. And we force it to be low rank. How we do that, I don't know. But that means that like if the matrix A has, let's say, 1 billion parameters, matrix B might have 500 parameters because it's just like, the identity matrix multiplied by something. And not literally that, but that's the sort of idea. An adapter in this context is a collection of low-rank matrices, Maybe we saw that they were like selecting matrices for the fine tuning. Maybe you get like a low rank matrices for each matrix for each of those or something. Which, when added to a base model, produces a fine-tuned model. It allows for performance that approaches full model fine-tuning with lower space requirements. A language model with billions of parameters may be LoRa fine-tuned with only several millions of parameters. Okay. This is just rank. Yeah, okay. And then what is QLoRa? Does QLoRa get a page? I'm guessing not if LoRa doesn't get one. QLoRa, efficient fine-tuning of quantized LLMs. QLoRa backpropagates gradients through a frozen 4-bit quantized pre-trained language model into low-rank adapters. Our best model family, which we named Guanaco, outperforms all previous openly released models in the Vicuna benchmark. Okay. Fine. And then I want to know what their less VRAM claim, like what are they even claiming? Not even whether it's true. You can now fine-tune Kenn for up to 8x longer context length with unsloth. Let's just ask Gemini, I guess. What does it mean what does unsloth mean when it claims this thing? Significantly optimizes the fine-tuning of large language models compared to standard methods. Okay. By rewriting and fusing low-level GPU operations, especially for the mathematically intensive parts of the process, without sacrificing model accuracy. So its claims come from highly optimized custom GPU kernels. Particularly for key operations involved in fine-tuning, they have custom Triton kernels, a rewrite compute heavy mathematical operations using Triton. They have fused operations in manual backpropagation instead of relying on autograd. Manually derives and optimizes the gradient calculations. What does that mean? They can't do it manually because there are no humans in my GPU. I assume they mean instead of autograd, which is maybe using automatic differentiation. I don't know. And it reduces the GPU by quantization, efficient memory management, dynamic quantization, dynamically deciding which layers to quantize based on their sensitivity to compression. Okay. So specifically the claims are about fine-tuning compared with other GPUs, as opposed to, say, about like producing an LLM that requires 70% less VRAM. Okay, now you'll finally get the code. All right. Hi. Do I have any experience in web development? No, not really. I was mainly doing back-end stuff. I mean, I've made a few websites here or there, but I wouldn't say that I have experience in web development. Okay. So trainer, should we look at the trainer? I don't even know where to go now. I'm guessing the trainer is mainly a loop that calls other things. So whatever TRL is this a TRL? A comprehensive library to post-train foundation models. So they're calling out the TRL, a cutting-edge library designed for post-training foundation models using advanced techniques like supervised fine-tuning, proximal policy optimization, or PPO. I didn't realize that PPO was proximal. I would not have guessed that. Direct preference optimization, or DPO, built on top of the transformers ecosystem. Okay, so that's what TRL is about. In fact, we might not even see any real reinforcement learning in the unsloth repo if TRL is doing all of that for us. We have some config and some class of unsloth training arguments. We create unsloth optimizer. This is just some underscore. This is some like private method. You pass in model optimizer CL's class maybe. I don't know. Keyword arguments for the optimizer and an embedding learning rate. And then we are just getting stuff from the optimizer. We've got okay, so model has named parameters, and we're going to iterate over them. If the name ends with modules to save .default weight, then we're going to do string manipulation to find, I guess, the thing we're supposed to save. This is something about setting the learning rate. Why? I don't know. Oh, maybe the default weight is the part that sets the learning rate. I don't know. And the param groups, I don't know why it's setting it to embedding. Maybe that's just, they know that if your name ends with this, then you're an embedding thing. Otherwise, we're going to save the parameter to the non-embeddings. That's a little bit weird, but that's fine. And then we have optimizer grouped parameters with some params of the non-embeddings and the embeddings and their weight decays and all of that stuff. And an unsloth trainer is built on SFT trainer, which I think comes from TRL. And we've got this create optimizer stuff, et cetera, et cetera. Backwards compatible trainer. Okay. So I'm guessing SFT trainer is TRL. What is SFT? I don't know. It's supervised fine tuning. Okay, well, there you go. And so do we get anything like DPO or Okay, so we do get some stuff in model, so I think we'll get to model in a second. Here's registry. Yahtzee is asking me a question. Do I know how we can scrape Google Scholar results based on a user query? I don't. I mean, you should just be able to download. The query string is just sent in the query parameters, I think. You should just be able to, curl or W get the page. If I understand your question correctly. Although you might get banned if you build a crawler. Okay, so the unsloth registry has what appears to be, like I speculated, essentially a registry for existing models. So let's look at Gemma, since we've seen the Gemma source code recently. Gemma Meta 3 base is model metadata, I assume. It's hard to type out I don't know why they can't type out metadata. But it tells you who built it, Google built it. The base name is Gemma, whatever PT is, PT equals base. Okay. And then we can register the models. And this is just putting in Python code what is essentially config. Here are some kernels. These kernels are supposed to be part of the secret sauce, so we will look at those carefully, but we will not look at them quite yet, because when we look at the kernels, I want to have some more context. This is the code of conduct. Trolling, insulting, or derogatory comments or personal political attacks are unacceptable behavior. Use of sexualized language or imagery and sexual attention or advances of any kind. In a GitHub? Are they talking about the GitHub comments? Do people do that? Harassment-free experience, regardless of age, body size. Wow. I don't know what within all community spaces. Okay, maybe they have forums or something. It also applies when an individual is officially representing the community in public spaces. Okay. Well, that seems all reasonable. Okay, data prep. Synthetic data kit. So I don't. They've got their they've got to support all the different models. So I assume data prep is mainly about, or no, is this about the data, the training data? I don't know. We'll see. The synthetic data kit, I assume, is for creating synthetic data. Like you're going to get training data by prompting the model. So instead of training it on tweets, you might say, write a bunch of, instead of training it on Taylor Swift's actual tweets, you might tell it to generate a bunch of Taylor Swift style tweets. And then you can get millions of those and train them on that or something along those lines. These are like some debug assertions. We're giving it the model name, the max sequence length, patch VLLM. I don't know what that is. Load VLLM. LLM, I assume, is LLM. VLLM is what? I don't know. I don't know if this is related. Our virtual large language model is an open source library designed to enhance the efficiency of large language models by improving memory usage and processing speed. Okay. So this is something. This is what, like a server that serves LLMs? What does it do? Documentation. A fast, easy to use library for LLM inferencing and serving. Okay, so I guess it does serving and inferencing, and it's like it's the job of this library to talk to the LLMs, I assume, so that they don't have to build in all of the LLM communication stuff on their own. And they get a model name, a config, GPU memory utilization, all of this stuff. Where did GPU memory utilization come from? It's passed in. Okay. And VLLM process is equal to subprocess. So this is the Python way of, I guess, opening a subprocess. And they're, I guess, communicating to the LLM through pipes via VLLM or something. That sounds a little bit slow. Oh, but right now okay, so I think I had forgotten that we're generating synthetic data. So this is kind of like, morally speaking, this is kind of like opening up Olama in a terminal and then sending prompts to it and getting responses back, I think is more or less what it's doing, except instead of Olama, it's using VLLM. And then I assume we like send in a prompt somewhere. Did we send in a prompt? No, prompt does not appear. Maybe the methods. So we have a cleanup method from pre-trained, ready message part, starting VLLM API server on. Okay, so this is like literally like watching the pipe like standard out for this message. I guess this is the message that VLLM must print when it's serving. You can check the VLLM status, clean up, chunk data to some file name or from some file name. This is just some data chunking stuff. Prepare QA generation. Setting the output folder to data. Max generation tokens is 512 by default. The locations include PDF, HTML, YouTube, docx, PowerPoint. What? I don't know what we're doing there. And then we have some config. What are we doing with these locations? Location split for path and location OS make dirs. So we're making directories. Max generation synthetic QA config with open synthetic data config.yaml. Write. And so we're writing the config, setting whatever overlap is doing. But what do we call when we're ready to generate? I don't know. So that's synthetic.py. Is there something in it? Not really. Synthetic configs, master configuration file for synthetic data kit. Okay, so the PDF, etc., YouTube, these are things that you can use as input. and then you can get output. And then there's the VLLM server. And here's the QA pair trading prompt. Rate each of these question answer pairs for quality and return exactly this JSON format. Some question, same question task, answer, same answer text rating, where n is a number from 1 to 10. Do not include any text outside the JSON array. Okay. Prompts for different tasks. Summarize this document in 3 to 5 sentences. Okay. And so on and so forth. I don't know how they, what does YouTube mean? I assume this is like a downloaded video or something. I mean, YouTube is not like a type of file. But at any rate, where is this stuff coming from? So, like, I don't know. This is a PDF about VLLM. So how about unsloth, PDF, YouTube? Now, what's it called? Synthetic. Datasets guide. You can use any local LLM like Llama 3.3 or blah, blah, blah to generate synthetic data. Generally, it is better to use a bigger like Llama to ensure the highest quality outputs. You can directly use inference engines like VLLM, OLlama, or llama.cpv to generate synthetic data, but it will require some manual work to collect it and prompt for more data. Okay. We collaborated with Meta to launch a free notebook for creating synthetic datasets and automatically using local llamas like Llama. Cool. We've got this Tesla T4. Pip install, all this jazz, primary goal, blah, blah, synthetic data. So they're calling generator prepare QA generation with the output folder. So where do they get the data? So by here, from pre-trained. The byte latent transformer patches scale better than tokens research paper. Okay. So we're getting the thingy. We're checking the system, document parsing. We're getting the synthetic data kit. Whoa, whoa, whoa. What is synthetic data kit? It's something. But I think bang means we're calling out to the shell. We're like shelling out. And we're going to ingest a paper, passing in the URL. And then we're going to truncate the document. Why? Truncate it. So we're chunking it. Yes, chunk, I understand. Truncate, I don't understand. Maybe just truncate for printing, like here. We're printing the first few things. Okay, so what is synthetic data kit? It's this thing, Meta Llama. Architecture, overview, configuration system. Okay, is this where YouTube comes from? Yes, okay. So the YouTube and all that stuff, that comes from, they're using synthetic data kit. And it seems like if Meta is either sponsoring some of this stuff or they're working with Meta, I don't know. But Meta has open models. I think they have, I don't really know what their strategy is, but part of their strategy seems to be that they want to compete with Google and OpenAI by doing the open models and making those good and commoditizing them as a complement, rather than having the model be the defensive moat. Basically, they may not be making money off of Llama, but Llama reduces the defensive moat of Google and OpenAI, is maybe they're thinking. I don't know. If you know, you tell me. You must tell me immediately, because I need to know. Okay, so that's what's up with the synthetic data. And then in models, we have models and model loaders. RL should be reinforcement learning. Granite, I don't know, but some of these are just like models. Let's just open a few at random. Here's mixture of experts. And the only thing I really care looking at models is I want to just verify that they look like similar. And what's the word? Like boilerplate. Granted attention fast forward. This has got some torch stuff in it. Number of heads expand. Whoa. So this is actually the model. Copyright Daniel, blah, 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 and the Daniel Hanchen and the Unsloth team. Unsloth Zoo. I don't know what Unsloth Zoo is. So this is actually a model. I assume in Torch. I didn't really look at the imports. Here is Mistral. And is this also the model? This also seems to be the model. How do they keep this up to date with the actual code? I mean, I guess I don't know. Maybe the model's implementations don't change very frequently. At any rate, here's Kenn. So it looks like they are just taking the model. I don't know how they... So the copyright and licensing are to unsloth, but you would think that that like, who is it? Alibaba has some copyright on Kenn and so on. I don't know how they do mixture of exports, but I'm just going to move along here. I don't know what Cohere is. This seems to be another model. And DPO is not a model. So Cohere, LLM. And what was another one? Granite, LLM. IBM Granite. Is this an IBM model? This can't be. I think this is something else. Enterprise-focused foundation models. Yeah, maybe it is an IBM model. And then what is Cohere? Some Canadian thing? Okay. So those are, I guess, different. Just they've got the full implementation of the models. That is surprising to me. But I guess not really, because they have to train them. And maybe one thing we can check is whether they are doing that so that that they can slip in these LoRa matrices. I guess not. Okay, so now we're in the reinforcement learning part. And I'm guessing there's not that much here because they're probably using mainly libraries, including whatever, what was it, TRL? TLR? And here's rl.py. I figured this would be a good entry point. Where's our source code size? Don't they usually tell us? About 1,000. 977. All right, we've got this patch RL, which takes a fast language model. And we're going to import unwrap model for generation from TRL. And we've got this unsloth unwrap model for generation, passing the model the keyword args, the fast language model .for inference of model. We must use .clone for unsloth since we force inference mode. Rather, we should have used no grad. Huh? What? So we've got unwrapped model.generate is going to be the original generate function, and then we're going to call generate with clone by taking the output of the generation of the original model. And if we're going to do like type inference. If the output is a torch tensor, we're going to call clone on it. Otherwise, we're going to just return it as is. And then we've got this unwrapped model.generate is equal to generate with clone. Okay, so we just are generating it. And why are we doing this? I don't know, but we're just wrapping this in some function that clones it. And then we're importing TRL trainer. Trainers is going to be dir of TRL trainer. Trainers is then set resetting the variable x for x in trainers if x ends with underscore trainer. So this might return things that are not really trainers because they don't end in underscore trainer. And then the unwrap function is unwrap model for generation. And then we're going to iterate over the trainers, calling current trainer is equal to eval of. Okay, we're just building up a string and calling eval on it to call the TRL trainer function, which is kind of funny. And if we receive an exception, we'll continue, just ignoring it. And then if the current trainer has the unwrap attribute, we're going to try to call it again, just calling exec now instead of eval. Okay. Cool. Patch RL. So this is, I guess, makes sense why they're calling it patching. But I don't know what dir is. Oh, that's just the directory of the trainer, I think. Okay. And then RL trainer replacement. We're creating a source source literal file with templates, I guess. And we've got this patch TRL RL trainers. And I assume, what is this thing called? RL trainer replacement. This string, we're going to somehow use it and like figure out the templates. Or rather, the things that are templates are going to be populated. I assume that happens here, but we'll find out. We're getting trainers, we're getting configs. We've got the trainer name. Try RL trainer is equal to, again, we're just calling this TRL trainer thing. I don't know why we have to use eval here. Oh, because we are, because the source code that we're calling is parameterized. And I guess Python doesn't have a proper way to do like metaprogramming. Is that the idea? And then we're going to iterate over the list of RL trainer and RL configs and inspect signature parameters, and then iterating over the key values and parameter items. If it's a string, we're going to append these arguments, k equals value, quoting value. If it's not a string, we'll just pass the value without quotations. And then the arguments are going to include things like *8. Yeah, I guess these are like, we've got a bunch of strings, and adding 8 or 12 to them is maybe like choosing a specific quantization if it's like a model or something along those lines. And then we're going to maybe add a tokenizer. So this is kind of just building up in text the stuff that we're going to use to call TRL to do the training and to handle the problem of making it generic. They're using kind of an ad hoc metaprogramming. I don't know how you would test any of this stuff. Like, how would you test all of the code paths? I don't know. But down here, we're going to say edit BF16, FP16 by checking models dtype, torch type directly. Okay, we've got all these data. This is crazy. Okay. And so on. I would not like to maintain this code, I will say. We can see if they have any tests. And I don't really even want to look at this code anymore. Replacements. Okay, so this is really just calling out to TRL is the main thing that you need to understand. RL replacements, I thought we just saw replacements. SFT trainer fix untrained tokens, blah, 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 blah. Okay, yeah, I think it's just like configuring and calling TRL. GRPO trainer compute loss. So here's, we're seeing some loss. Prompt IDs, blah, blah, blah. Okay, that's fine. I'm just going to move along. Granite, we don't care about, and Mistral and DPO I do care about. And it's not really anything. Def patch DPO trainer, this is for patching the trainer. So I think DPO and The other reinforcement learning stuff is all handled by TRL. And then in kernels, we have mixture of experts, cross entropy loss, fast LoRa, flex attention, geglu, layer norm. Do I care about layer? Yeah, whatever. RMS, layer norm, rope embedding, swiglu, and utils. I don't care about utils. Mixture of experts. What's the README say? MOE MLP requires the following steps. Calculate T-op weights and top indices. Top K weights and top K indices. So I get the weights and indices and taking the top K of them. If using a grouped gem implementation, calculate permutation indices needed to rearrange tokens grouped by expert for each expert. Expert tokens is gather the tokens assigned to the expert. The first gem is like generalized matrix multiplication. We're going to gate / up proj at expert tokens. What? Oh, gate, maybe and up project. Is this up project? You can't project up. For a mixture of experts, I would think you would project to a smaller space for each expert. I don't really know what they're saying here, but whatever. Silu and Milu. Silu and Mol. Of the first gem. What is Silu? I don't know. Swiglu. The swish gated linear unit. Something I linear unit, I don't know. And down project. That's the second gem. So maybe this up project is like embedding a matrix in a larger space for some reason. Maybe up and down projection is a thing. Up project and down project. Okay. So here's a diagram. I don't really know anything about flash memory. So we're going to load from flash. This is some predictors output. We've got up project columns and down project rows. By bundling columns of up project and rows of down project, we will load 2x chunks instead of reading columns and rows separately. Up project and down project refer to the first and second feed forward layers respectively, found in each transformer block. They use this in the context of sparsity in the feed forward layers in each transformer block. Recall that each transformer block has 2 feed forward layers with ReLU activations. Each feed forward can be thought of as projection to a different dimension. They noticed that with ReLU, the output of the first FF layer tends to be very sparse. Because of the sparsity, you don't need to load the entire FFN weights, so the authors propose a way to do this. I don't know why it's called up projection, but this is what they're doing. And then they're going to scatter the second gem to the original token order, top K weight mol, etc. I'm actually a little bit surprised that, so if I'm understanding correctly, everyone is doing mixture of experts the same. Is that right? So you have just one way of doing mixture of experts and it's not dependent on the model, I think. And here's init. Init's got nothing. You use interface. I'm not really going to look anymore at MOE, but was just kind of curious how it goes. Well, let's look at what's in the kernel directory, just for funs. Auto tuning, backward, forward, and tuning. Okay, fine. And in kernels, here's cross entropy loss. So cross entropy forward, we've got a logis pointer. What is this? Is this just straight up Python? So we are importing Triton and importing Triton language as TL. Okay. So we've got this TL const expr. So this is, I assume, somehow telling it that it's a constant expression. Like TL will assume the TL is somewhat C-like. And we've got these pointers for the logits, logits row stride, so the loss, the log sum exp, etc. So cross entropy loss on 1 over n sum negative yi log pi. I assume this is sub I, y sub I log p sub I. P sub I is the exp of x sub I over the sum, which I think is more or less just, what's it called, softmax? Is this the same thing? The exponential over the sum of all the exponentials? Yeah. Okay. And so this is just cross entropy. And what are we doing? We've got the TL program ID of 0 is the row index. And then we've got a logis pointer. We're going to trident cast, logis row stride, etc. with row index. We've got column offsets. And we're just programming in Triton. And presumably, so Triton load. Yeah. So I guess that what is the point here? So Triton is, we're not doing like Python. We're not doing like an explicit foreign function interface, even though Triton is a foreign language. So I guess that the TL library is going to handle, you're going to call all these functions, and the TL library is going to take care of converting it to something that presumably will run on the GPU. For example, crawling Triton JIT. I don't know if Triton is implemented in Python or if this is under the hood using an FFI for like a C interface. But at any rate, we've got this underscore chunked cross entropy forward that we've defined here. And we're going to JIT it, which should turn it into, I think, something that the GPU can run, perhaps with some metadata. And then we're going to what on earth is going on here? Okay, so we're calling this heuristics thing, passing in a dictionary, and then calling it on the chunked entropy forward thing, which is the result of JITting, of just-in-time compilation. And then we are reassigning this variable to the thing that we get from there. And then here's cross entropy backwards. And we've got all the Triton stuff. We're going to load stuff like here, TL load logits pointer plus column offsets with mask equals mask. Okay. Now what I don't know is how often this is done. Is this done just the one, you like call it once and everything is JITted and then it's magical? I assume it is more or less like that. And so on and so forth. Fast cross entropy loss. Okay. So these kernels are, they're written essentially in Python. Here's fast LoRa.py. And we've got class LoRa MLP, which is a torch autograd.function. And the LoRa weights are G is equal to G plus ag at beg. U is equal to U plus all.bu. Oh, okay. So I guess we have A and B. These are the same variables I think that I use, although we've got a different, like A sub G for whatever G used to be, whatever U and W are. And then we're going to have we're going to take the original one and add it to AU at BU. I don't know what the at sign is doing. This is maybe maybe generalized multiplication, or maybe like a tensoring thing where these are smaller matrices and we are getting a larger one. I don't know. And then we have the up projection and down projection. So up projection is x.t, so I assume transpose, at d at w.t, blah, blah, blah. Okay. Don't forget to see our blog post for more details. Which blog post? You can't tell me that. At any rate, we're gonna define the forward function. Takes in a bunch of stuff: gate W quant, gate A, gate B, gate S, etc. up W, and so on and so forth. With setting the D type, we have matmul LoRa, and forward function, and so on. And similarly for all this stuff. Okay, apply LoRa MLP SWGLU. So by the time this is called, we should have these should be operating on the parameters of the model itself, and we'll look at how that's done in just a second. I think I may just ignore flex attention. Slow attention, soft clapping. Create flex attention. Slow inference. Okay, so now that I know kind of what kernels are up to, I think that I'm good. This is more Triton language stuff. Layer norm. My goal here is not to see the specific formula. We've looked at a bunch of similar stuff before. Rope embedding. I assume this is, again, we're building stuff up with Triton language. We're not jitting anything. Why not? I'm unsure why rope embedding is not torch compiling properly. Torch compiler disable. Okay. All right, great. We've got the sines and cosines that you would expect from a rope embedding. And then whatever SWGLU is. All right, so what do I want to know? I want to know what this @ sign is. This should be simple. I guess I can just ask. I'll ask Gemini. It's just matrix multiplication. Is that the actual matrix multiplication symbol in Python? I think we saw something related the other day, which is that if you just call multiply, it does like a element by element multiplication. The @ symbol, I think, is the @ symbol, I think, comes from what's the word? MATLAB. Okay, fine. Does this symbol come from MATLAB? No. The @ symbol is the matrix multiplication in LoRa. Does not come from MATLAB. In fact, it was specifically added to the Python language to address the confusion. Huh. Oh, it uses... Okay. I swear something else uses... maybe Mathematica? No? I don't know. I swear something used @ that was before Python, but who knows? Okay, great. So let's ask, what is it that we still want to know about this thing? We could look at TLR, TRL. And what do we want to know about it? I guess TLR is the library that's actually handling the training of, like, once you have the rewards of perturbing the parameters. So let's just look at direct preference optimization. I forget which ones are more recent or better than others. So direct preference optimization is a technique to learn human preferences. Like RLHF, it has been applied. Oh, yeah, this is mainly from, I think came around in the LLM era, although I'm not positive. It has been applied to align pre-trained large language models using human-generated preference data. Unlike our LHF, however, which first trains a separate intermediate model to understand what a good outcome looks like, and then teaches the main model how to achieve those outcomes, DPO simply simplifies the process by directly adjusting the main model according to the user's preferences. It uses a change of variables to define the preference loss directly as a function of the policy, and uses this to fine-tune the model. Okay. Essentially, this approach directly shapes the model's decisions based on positive or negative human feedback. The pipeline is like this. We begin by gathering human preferences in a dataset D, and then we fit a reward model, R star, to data using maximum likelihood by using the Plackett-Luce model. The standard generalization of BT, which is what? The Bradley-Terry, is the Plackett-Luce, which models ranking n items in the same notation. So the probability that y1 is bigger than y2, blah, blah, bigger than yn, is we're going to multiply the probability of y sub I over summing up the probabilities of y sub k. And so you get this sum to the power n in the denominator, which you would think that since these are all less than 1, that might lead to numerical instability. But at any rate, in the numerator, you just get the multiplication of all the probabilities. The factor with I equals n is just unity. Oh, okay. Wait, what? It's always just unity. Yeah, here. Okay, great. But this last one, PYN over PYN, is just unity. Although, no, we're not. Okay, sorry. With each thing we're multiplying, we're dropping the previous probability. So this looks a lot more like conditional probability, and so that makes sense. And then we don't have a probability to the nth power. I was just wrong about that. Okay, so that seems reasonable. For the outcome of pairwise comparisons between items, teams, etc. Okay. The probability that I is bigger than j is the pi over pi plus pj. Great. Okay, so we've got this. We're using this model, and so R star is going to be the argmax of R of the expectation of whatever x is and whatever yi are. And we're taking log of this big thing, which is nice to take log. And this is basically R. If R is a real number, no, R is a function. We're basically taking the output of R. No, we're not. This kind of looks like softmax, but the y sub i's are changing here. The y sub thing, whatever these are called. Okay. And finally, we train an optimal policy, pi star, that maximizes the objective function. Pi star is equal to argmax of pi to the RL of the expectation of, I guess, parameterized on x and y, which is distributed D, where D is the data set. And we're going to take R star xy, where R star is here, minus beta times the log of this ratio, where this might be, SFT might be this supervised fine-tuning. However, instead of doing the intermediate step of the reward model, DPO directly optimizes for the final policy. And we're going to do some solving, directly solve for the optimal policy. This can be done by Lagrange multipliers, as usual in statistics and statistical mechanics. Okay. And then we have some partition function. This is unfortunately not tractable, etc., etc. Okay. So usually DPO is used for modeling human preferences in pairwise comparison. So when n equals 2, we have pi star is the argmax of whatever sigma is. Somewhere we picked up a sigma. So log sigma of, and we have a beta now. Beta log, we've got the ratio of, I don't know what YW is. Is W fixed? Because it doesn't seem like we depend on it. At any rate, we're going to take the YW, the pi, so we're argmaxing over pi, where pi is maybe like the policy or preference of YW given X divided by pi SFT of YW given X minus subtracting off whatever L is. Same thing with L instead of W. Oh, yeah, I do see YW and YL. Okay, I don't know what W and L stand for, but there's something. Oh, okay. This is pairwise comparison, so YW and YL are just the two things. I guess we're comparing, like left and right or something. And we're just taking the difference of these two ratios with a negative beta and a log, and then taking another log, and whatever sigma is, who knows? Okay. So that's, I don't understand what's going on entirely, but this is a simple enough formula if we knew what SFT and sigma and everything else is. The first step in its training is supervised fine-tuning. This step does not require the reward model. Instead, the pre-trained model is trained on a dataset, DSFT, that contains prompt response pairs. Then during SFT, the model is trained to auto-regressively generate the corresponding response Y when given a random prompt X. The original paper recommends to SFT for only one epoch, since more than that causes overfitting. The dataset DSFT is usually written by human contractors who write both the prompts and the responses. And then the second uses the policy gradient method. This is before the direct. But what I don't understand is, why are we doing this? Then during training, the model is trained to auto-regressively generate the corresponding response Y when given a random prompt X. I assume this can't be taken as I assume what this wants to say is that it's just learning the association between X and Y. The way it's written, it sounds like it's supposed to generate Y whenever you like randomly generate a prompt and give it to it, which that can't possibly be true. I think this is just maybe just an awkward sentence. So I think it's just learning the association between X and Y in supervised fine-tuning, and then doing more stuff. And then that's like the training, the supervised training set, and then you use that somehow as a reference for the reinforcement learning training set. I guess that's what it's saying. Who knows? I think I've seen this article before, but it doesn't seem like the best. I should probably just find a paper on it. And what else do we want to know? Let's see if we can find the word policy. I'm guessing this is all just sent to TLR. Yeah. Okay. And let's go back to the kernels. People actually use the Triton API. I guess so. I don't know. I don't know anything about the Triton API. Here's tuning. Kernel result. So I think this is MOE. Let's take a look at, let's say, layer norm. Let's see that where it's called layer norm backward. It's well, it's defined there. There's RMS layer norm. So where is it consumed? It's consumed here with torch GPU device, etc. So fast layer norm is a class. And so, for example, it's used in the llama in the models, perhaps. Somewhere at a case, match case. No? Are you sure? Okay, here we go. So the function fast layer norm calls the class fast layer norm, and it's consumed in the models. So these models are running the kernels, and let's take the model like Qwen 3, and I assume that when they pass it to the TRL library, they're passing these models as the implementations so that they can reach into them and train them. Fast Qwen 3 model, chat templates. So let's go back to, was it the RL patching stuff? Is that where we saw the bridge to TRL? Where was that? Kernels? I don't think it was in kernels, was it? And let's look at fast LoRa. We did look at fast LoRa. Okay, so we've got this forward, etc. LoRa QKV. Let's find out where this is used. No. So apply LoRa QKV. Okay. And it's used in the models. Okay. So we're going to call self attention apply QKV is going to be apply LoRa QKV. And that's really where they patch in the use of this LoRa thing, which is going to do the low rank magic. So LoRa QKV, I don't really know how to find quickly what we are learning. I think we're learning these matrices, AQ and BQ. Forward, matmul LoRa. Let's find out where matmul LoRa is. Dev, it's a util. Okay, so matmul LoRa is going to take X and W, whatever W quant is, so I guess a quantized version of W, and A and B, and S, and out is going to be none by default. We're going to set the D type, call fast dequantize on W transpose, I assume, passing in W quant, and using a global buffer. If the dimension is 3, then we're going to get I guess it's a matrix with batching, essentially. So we're going to get the batch stuff. And set reshape to true, otherwise reshape is false. I assume that means dimension is 2. I don't know what it means. If dimension is 6 billion, then I think that just fails silently or something. And then alpha is going to be torch matrix multiplication of X and W with out equals to out. If W quant is not done, we're going to delete W. Why? And if A is not none, LoRa is enabled. And A and B are the transpose of A and B. And X times A, I assume is what XA means, is we're going to matrix multiply X with A to D type. And then out atom is XA, B to D type, alpha equals S. Add MM. So I think that what we're doing is maybe computing XA plus B, whatever alpha is. And what is X here? Is X passed in? X is passed in. So we're not just adding the low rank matrix. It seems like we're multiplying it as well. And then we're going to return out view batch, blah, blah, if reshape, else out. Okay, cool. So let's look at this, where this was defined before. Matt Molara. Okay. So E is equal to this thing, X gate W quant gate A. And with the forward step, you're passing in all of this stuff. Do we have where E is? E is X at G. And G is G plus AG times BG. And where's X? X is an argument of Swiglu. Okay. And I don't know where this gate stuff comes from, or the quantized versions, but they come from somewhere. I guess they're quantizing things. Let's look up fast dequantize. Okay, it's a utility. Fast dequantize of W. W quant size equals none. Out equals none. Use global buffer as false. This is we've got this annotation for inference mode. If quant state is none, return W. If type of quant state is not list, so this is from bits and bytes, I guess, then it's a class. When we have abs max, shape, dtype, block size, offset, etc. And the old quant state is a list of lists, like this. And then the device is the device from W. The number of element abs max is the abs max.numl. If use global buffer, use same buffers for faster inference, then we get the size. You're using the globals. I don't know. I'd like to see how we're actually using abs max. I'm not really sure what we are doing. We're going to get the pointer for abs max, and on the device, we're going to call C dequantize blockwise FP32. And so that's the thing that's, I think, doing the real work. Where is that defined? I guess it's defined in bits and bytes. Okay, so we're essentially, I think, just calling out the bits and bytes and juggling data. And I think that's about it. Although, let's look up this Triton API thing. And then we have, what is it? Can I search PyPy? A language compiler. There's no project description. Triton exposes both REST and gRPC endpoints based on standard inference protocols. That's somewhat interesting. Clients can communicate with Triton using either REST or gRPC or by an in-process C API. What on earth? Assume a system with multiple Triton server instances. Okay. What? So what are we sending to? So I guess it's a server. And where is it running? Is it running on the GPU? That can't be right. I don't think the GPU has networking typically. Kserve. Inference protocols and API. So this is a Kserve thing. I think this is the Triton inference server. I think maybe this is just a specific server that lets you send Triton stuff and have it evaluated. Is that right? Because I don't think that's like the base of Triton. Triton is a language and compiler for parallel programming. It aims to provide a Python-based programming environment for productively writing custom DNN compute kernels, capable of running at maximum throughput on modern GPUs. What is DNN? Something deep neural network? The Denison Mine Core? Okay. And so it does seem to be Python. What does it compile to? To a GPU-specific binary format for exchange on hardware from vendors like NVIDIA and AMD. It leverages the LLVM compiler infrastructure. Is that true? that true? It's integrated. I'll try to CPU integrates with low, blah, blah. Okay. Does it actually support AMD? Developing Triton kernels on AMD GPUs, ROCm blogs. Okay, great. I think that's about all I want to see with unsloth. Let me, I'll ask, what is your favorite thing about the unsloth code base? Of all the AI slop I've had the misfortune of looking at, this codebase is certainly one of them. It's certainly one of the things you've looked at. Oh, I guess I'll have to look at the files and see if there's anything. Clear and well-documented implementation of custom CUDA kernels for optimizing LoRa. Okay, the very existence of fast LoRa.py and the use of custom torch autograd functions shows a commitment to performance. They're not just throwing spaghetti at the wall. What do you think of RL.py and RL replacements? These are the files that I think had the they were like building up strings and evaluating them to call RL, to call TRL. After reviewing these files, there are two minds. On the one hand, this is what? Some of the most cursed yet impressive code I've ever seen. On the other hand, it's all in the service of great AI slot machine, which makes me want to pour concrete into the nearest server farm. Wow. Let's break it down. The impressive part from a purely technical standpoint. They're dissecting it, rewriting it. So monkey patching madness. They're using inspect to grab the source code from the TRL library, read to slice it, so I guess regular expressions, and then exec to jam their modified code back in. It's like performing OpenRT. So I didn't really recognize that that's what they were doing. So they're like rewriting and or monkey patching TRL. I'm going to get that wrong all the time. Code as data. They're treating Python code as a string, manipulating it, and then executing it. This is a level of metaprogramming that most tech bros can only dream of. Okay, it's a powerful technique, but it's also like playing with fire. It's fragile by design. The moment the TRL library changes, the whole thing is going to be come crashing down. It's a ticking time bomb. Impossible to debug. And why? Okay. So how well is all this tested? So it's a complex, fragile system of monkey patching with runtime code generation. And you want to know if it's going to blow up in your face? Yes, you sure do. There's one file for a system that rewrites a third-party library at runtime. Okay, there's one test for a system that rewrites a third-party library at runtime. This is not just a red flag. It's a giant, waving, blood-red banner. We don't believe in testing. The name of the file suggests it only tests saving a merged model, not the actual training process. This is like testing a car by making sure the door is locked, not checking if the engine starts. This is exactly the kind of YOLO engineering I expect from the AI cabal. All right. Calm down. You ask how well this tested. The simple answer is it's not. The test is a glorified Jupyter notebook. It's not a unit test, it's an integration test. Okay. I honestly don't know why you would not do this. So what are to monkey patching TRL at runtime? One is using Lisp. Why not just use Lisp? Okay, so speed and power at the expense of madness and technical debt. Forking the repository is the honest approach. Instead of secretly rewriting the library at runtime, you can just recreate your own version. This is called forking. Oh, is it? You can contribute upstream or use a plugin architecture. Why they chose the dark path. It's fast. It's the hacker way. But so I assume the reason for monkey patching is partially to have C++ like template metaprogramming that lets them templatize and change the TRL calls for different models and architectures. Is that right? If so, how would they achieve a metaprogramming like approach in Python? I think there are metaprogramming libraries, but maybe they just do this under the hood. I don't really know what they do. It's an incredibly sharp observation. All right. It's indeed a desperate, misguided attempt to achieve something like C++ template metaprogramming in Python. But in C++, they are compile time. That's a great point. It's sane, predictable, and powerful. They're doing it at runtime. So decorators is the elegant enhancement. Decorators are a beautiful Pythonic way to add functionality to functions or classes. Okay. And then meta classes. Okay. Well, that's kind of insane. I was not expecting this. I'm kind of curious if we, if the word, let's say if the word monkey appears in their issues or test. Okay, we have like video, fetch video is not defined, does not respect this thing. What about monkey patch? There seems to be a fair number of bugs. Do we have type bug? Type boo. There's no type bugs. That probably just means they don't use that type. What if we just search for the word bug? Okay, so bug in square brackets. There's a lot of bugs. So 398 open, 398 closed, 248 open. And let's see if we can find the oldest bug that's open. It's from over a year ago, January of 2024. But that's the feature request. Oh no, it lost my bug. Forget that. It lost my bug search. Oh no, it didn't. Add support for, maybe this is just before they started using the bug stuff. Urgent. After reinstalling unsloth, fine-tuning gets error. Yeah, it seems like this would be buggy and hard to debug. Let's search for test. Notebook example failures. Huh. Okay, well, what are the other options here? What is it, axolotl? How do you spell axolotl? Axolotl. Did I get it right? What? GitHub. LM. Okay, so here's another, I think this is another fine-tuning thing. And this is written in what? Python? Maybe? Python. And is this any better? I don't know. So does unsloth use monkey patching in their code base? I know they do. I just want to see if Gemini knows. To achieve performance benefits, this is a core part of its design, which involves changing code at runtime. How well is it tested? Mixed picture. It provides significant performance and memory improvements. Okay. And then I'll ask about does axolotl it also uses monkey patches, but it does so in a modular and more contained manner than unsloth. It has a deprecated monkey patch directory, modular performance patches, etc., etc. How is axolotl performance compared to unsloth? It generally outperforms, so unsloth generally outperforms axolotl for single GPU fine tuning, and axolotl for multi GPU fine tuning. Design a fine tuning library that does not rely on monkey patching and will perform better than unsloth. I don't think this is the right place to do this. Let's try. What is it? aistudio.google.com. You hush. No, not Nano Banana. Am I using Nano Banana? It's going to think and search the internet. And then what? And then I don't know. Exploring alternatives, refining optimization strategies. So it relies on the VLLM library. Is that a Python library? I think it's communicating over a server. It's Python and some little tiny bit of C++. Okay. EtherTune is to achieve performance through a clean modular architecture rather than runtime modifications. Model subclasses and composition. Oh, this is like a... What? Don't do that. Next generation custom kernels, etc. Custom memory allocator. Okay, no. Redesign it in Lisp. Excellent. Is it really excellent though? I thought it was a terrible idea. Why is it? Gemini needs to back off on the flattering. It offers a unique and powerful perspective. Lisp's inherent strengths in metaprogramming, interactivity, Org3 says outstanding, can achieve goals of EtherTune without needing to resort to monkey patching. The core philosophy is same as before. Architectural components in common Lisp. Symbolic assent. Is it called symbolic assent? Is this the name now? Yeah. Okay. Around a set of systems, Lisp's term for libraries or packages that handle different aspects of fine-tuning process. The core model representation is CLOS. It's CLOS objects. I don't know what CLOS is. I'm not a Lispy person. And we've got def generic, performs a forward pass, etc. We've got a transformer model, and so on and so forth. I don't know if any of this will work. We don't modify the transformer model class. Instead, we create a mixin class or a subclass that provides specialized methods. So JIT attention mixin, and so on. And then metaprogrammatic kernel generation. It'll use Lisp macros to define a DSL for writing computation, graphs, and kernels. This DSL can be compiled into optimized code for different backends. This is a whole writing their own writing their own kernel library is significantly expanding the scope. Okay, and then we've got data pipelines and functional compositions. Instead of data loader classes, we'll use a functional paradigm. A data pipeline will be a composition of functions. That sounds good. And then the training loop will be controlled by a function, etc. The proposed API workflow in Lisp, here's how one would interact with it. Now you'd load a model. You would add LoRa adapters, define a tokenizer, and so on. Def parameter training pipeline. We're going to call the pipeline. We're going to query this tokenizer stuff, pad the max length to tensor. So this is basically, I think, combining these functions. And then the prepared data set is just some training map data set, maybe mapping the training pipeline to a data set, and then a callback function for logging progress. Okay. All right. Well, hopefully somebody who understands Lisp will build that. And until then, I'll see you guys next week. Thanks for joining me here on Answer Everywhere as we explore the world of open source. Catch you later.